Afternoon. So I am excited to introduce our next speaker. It is Max Tkacz, and I am going to be sorry, I tried to pronounce your name properly. He is a staff developer advocate at NAN. He was as an early team member. He's worn many hats, from founding head of design to his current role as an advocate. He describes himself as the original programmer and is very much on brand today with his t-shirt, and he's spreading the low-code revolution. In his session today, Max is going to take us through transforming a naive customer support agent into a production-ready one, utilizing techniques including evaluation frameworks, human-in-the-loop safeguards, prompt injection protection, and robust fallback mechanisms. So please give it up for Max.
Conference. It's a pleasure to be here today. Oh, there's the microphone. So I'm Max, the original Flowgrammer. Thank you for the lovely introduction. And for the last 5 years, we've been building N8N, and we've been getting into agentic AI. So I'm really excited to show you a lot of the things that we've learned from all of our customers doing just that. And so yeah, this is the AI agent path to prod, building for reliability. Now, I'm going to use N8N to build this because they're my employer and they paid a pretty penny for me to be here, so I'm going to use N8N. But I tried to design this in a way that the learnings you're going to take from this, the layers that we need to apply to a naive agent, to a V1, can be applied in any framework that you're doing, be it with code or in a visual builder. And why should you trust what I'm saying today? Why should you listen to me today? If you check my career history, I was a product designer, etc. Well, it's because N8N today has over 1.3 million workflows live in prod. Since our users can self-host as well, that's an underrepresentation because not everyone's reporting that. And why should you trust me saying this to you? Well, because I joined N8N as our first designer. We built out the platform. And as a product designer, you talk with your users. Now, our users are technical most of the time, so they're more of an engineering type than a non-engineering type. And in talking with those users over the years, I got so inspired by their stories and I learned so much from them because it's their job to actually go build something and launch it in prod. Which is why I jumped into developer advocacy, because I basically pitched to N8N the best way that we could tell the story of N8N, of our users, and to grow this thing and to share the good word, so to speak, is to just tell the stories of our users who are all learning amazing things every day, building with these tools, especially at this nascent stage where we're all kind of building and figuring it out. And so I started as a product designer at N8N, as a head of design. I moved into DevRel, and these days I do just that. I tell the story of our community through our YouTube channel. We just broke 100,000. 100,000 followers, so I do recommend that you check that out. If anything here was interesting for a deeper dive, that is the end of the selling. We're now going to go into building, etc. But why am I giving specifically this talk? There's a lot of things I could show you in N8N on AI, tool use, etc. But it's because I think there's a big discourse right now around AI agents and around them not being very reliable, right? And that discourse is valid. And I think for a lot of reasons, some of the infrastructure around evals and all the kinds of things and guardrails that you might put on an AI agent are nascent. What I'm going to be showing you today is in beta. Similarly, models are advancing very rapidly. Some of the things I would have told you a year ago are maybe not so relevant today because this tool use is increasing. And particularly for AI agents, that's important because an AI agent has to do multiple steps to complete your task. So if each one of those steps today is 95% likely to complete, the probability of 95% times 95% times 95%, that final probability is lower than any one of those. And so that's why AI agents can get a bad rep, because some of it's true. The technology is evolving. And the other reason, I think, is because people bite off way too big of a scope. To get VC funding, you want to say, hey, this replaces a junior, this replaces a senior, no one's going to have a job tomorrow. But what I'm really seeing from a lot of our customers is more task-based agents today. They're building and they're learning and they're iterating at the task level. And they're preparing their organization also to accept the whole pipeline needed around delivering that reliably, but they're ready for when these systems get better to have more comprehensive agents. So today, I'm going to walk you through a use case that's inspired exactly by pain points at N8N as we're scaling, and we're going to do that with Yak, yet another Copilot. So Yak just launched a Copilot. They're growing massively, and they've got some pain points. And so the first thing I talked about is that people pick too big of a scope on their AI agent, right? So when we're looking at this case, we're saying, how might we reduce the burden on our human support agents, right? That's like the thing that we actually want to get done. The technology that we end up using to the non-engineers, to the stakeholders in the room, isn't so important, right? But so when we look at a pie chart of how we might answer this question, how we might help our customer support team, we can look at the different buckets of things that they're dealing with. And Yak, a fictional company, gets about 15% of their tickets are free trial-related tickets. So people want to extend their free trial. And this is rather drudgerous work for the people doing it. And it's relatively low risk. Because let's say we build an AI agent and it extends the free trial by some days. That's lower risk than, let's say, a GDPR bot that's supposed to delete user data. So this is a great example of where we're going to start. And what I'm going to show you today is an AI agent that I built, an naive AI agent that does handle these free trial requests, and then we're going to add evals and other things on top so that they're reliable. So I already teased the first step on getting an AI agent to prod, but that's establishing a viable solution scope. And that goalpost is going to change month on month as the technology evolves, but that's the very first step. So let's say we've done that. We want to help solve these free trial requests. Okay, check. Next, we want to build an AI agent. I've already done that. We got lots of content and stuff on building AI agents. I'll walk you through it so you understand how it works, but we won't build that out. But what we'll focus on is adding evaluations. That's going to be the main focus of my talk. I'm going to touch on some of the other guardrails. The one thing I want to, as a little asterisk, if you kind of read the blurb of my talk, is we are going to go through the different steps that you take an AI agent to prod. We're not, with the 30-minute time slot that I have, going to go into every single detail of that. Some of the evals you're going to see me running, I'm going to run 3 of them when you should instead run 10. I'll note those exceptions, but don't take this talk as, great, I know everything that I need to do to go launch a psychologist that is helping people with therapy, for example. And so once you've applied those guardrails, once you've launched a prod, you need to monitor that use case and identify where it's failing in the real world so that you can expand your eval test case, so you can iterate on your agent, and so that you can improve it over time. A lot of the things that I'm going to be showing you today, if you have an engineering background, it's similar to a lot of the things that you do in engineering, just with some tweaks on the context. So if you have an engineering background, you can still use a lot of those skills to deliver these agents. All right. This looks like it's a note for me to actually switch into N8N and start building. So let's go ahead and do that. So I'm in my N8N workspace right now, and I'm in the yet another Copilot folder, sorry. And let's open up the first part of this workflow. Now, this is not the AI agent that we're going to build, but this is how this use case starts. So let's actually run it with some test data here. And we can see in here the workflow is running. And the first thing we do, we have a webhook trigger. So Zendesk pings this webhook. We're using Zendesk as our ticket source that our customer support team works in. And when a new ticket comes in, the first thing we do is we enrich that information, and then we merge that. So there's no AI here yet. We don't need it. We're just fetching some context. And then we have an AI step that's categorizing that ticket, be it free trial, one of the standard categories, or something else. And then in here, as a sub-workflow, I have my actual AI agent. The reason I like to separate ingress and whatnot, as you'll see, we're, for the rest of this, going to focus on my AI agent itself, make sure that that's working reliably, and then separately, if we're going to prod, this workflow itself should also have some tests, etc. But we're going to focus just on the AI agent, because there's actually some more meat on the bone there. So let's go ahead and open that AI agent. But know that this AI agent is being invoked as if it were a function. So we define the workflow that we want to run. It's a sub-workflow. It's an AI agent in this case, but it could be any workflow. And then we pass in various details that we got early in my workflow. OK, so let's go ahead and open up that AI agent. OK, in here, I've got an execute workflow trigger. This has some pinned data in here. If I make this a little bit bigger, you can see in there we've got that data from before, coming from my parent workflow. And let's go ahead and run this, and I'll walk you through the agent as it's running. So in N8N, AI agents have one of many dependencies. They always need to have something for inference. In this case, apologies, in this case I'm using GPT 4.1. They can have one-to-many tools to get context from the world. And in this case, we also have structured output, so that the output of my AI agent is coming out in a structured JSON object. So if we take a look at my AI agent, we can see that the description or the incoming message was, hey, I'd like to present Yak internally. Our trial just ran out. Could we extend it by a couple of days? In the user message, we can see that we're piping in data from earlier in my workflow. This is what my LLM is going to see as the task. And then we also have a system message. This is my naive system message. This is my V1. I just wrote it. I ran this. It looks like it's working. But a rather basic one. We have a role. And then just a few rules about a trial extension policy. So at Yak, you can have a total of 14 days extended. And above that, it has to be assigned to a human if you request more than that. So in this case, we can look at the logs for this run that we just ran. And we can see that we first had a thought what to do next. The AI agent then decided to use the fetch trial extensions tool, which made a query to search for this email, which is the email from in here. And we saw that there are some previous extensions already. And then we used the extend trial tool. The agent decided to extend by 7 days for this user. It added a public reply to the user as well. It then logged the trial extensions, etc. And it's able to do this because in my workflow, for example, if I go in here, I have a description for this tool, but I've defined various parameters that my AI agent is allowed to populate at runtime. So the AI agent sees this as a web form, and it populates these parameters. Now, this ran. We did extend the trial. We did send the user a public reply, but we didn't set an internal note, which is something that we like to do at Yak. Every time someone does something, you want to set an internal note. And even though this ran, I have no idea how often this runs well. Does this run 50% of the time, 60% of the time? We're not sure. So let's do some evaluations on it, which are basically tests on my workflow, and get some confidence that this happy path case is working. And to do that, I'm going to go to a different version of the workflow. And it's the same AI agent, but it's now got evals attached to it. So evals and N8N live in the same workflow. So we've got that original trigger. I've got my evaluation trigger in here that's going to pull my evaluation cases from Google Sheets. Let's just make that a little bit bigger for you. It runs, and then there's a check if we're doing an evaluation run. If we are, we're going to evaluate the tools that we were calling in my AI agent, that log that you just saw. And then we're going to evaluate qualitatively the contents of the message sent, the public reply and the internal reply. And then we'll reset our database for testing purposes. In my test cases here, we can see, actually, we're going to start off with just the happy path case. So I'll start off with those first. Let's just copy this into a new sheet for now. But here I have a happy path case. So, hi Yak team, can I get some more time on my trial? I'm going to employ repetitions here. So it's a happy path test case. We ran it once in the UI and we think it worked. So if I do it one here, that's not really much better than that. So I'm going to do 3 repetitions of the same case. It resets the Superbase state after each run. And that better be consistent, because if 3 cases aren't consistent, then why would 10 be, right? So that's the first thing I'm going to do. And I do recommend that you start with your happy path case, get repetitions on that, get confidence in that, and then start testing edge cases. So let's go ahead and do that. And to do that, I can go over into the evaluations section here, and I can go ahead and run this test. While that's running, we can see those executions in the execution tab. So we can see we've got an eval running here. Those 3 will run, and then we'll be able to look at the results of that run. At the same time, there's various other values that I can compare across test runs as we go, although that's not so relevant right now because it's the first test run that we're doing here together. Okay, let's go have a look at some of these executions while they're running. Seems like we may have gotten an error in one. Let's see what that's all about. All right, it looks like ChatGPT had an error, so let's debug that. This was not planned. Let's have a look in here. Okay. This all looks correct. So what we're going to do is run it again. And if we're having some issues, this was not planned, we're going to swap to a different AI model because models go down, which is something you can do in end-to-end. But let's have a look at this and see which ones did run. Okay. So in this test case, we've got the public replies working rather well. We've got the tool call eval working rather well. So what we're doing in this evaluation is we have an array of objects. Each one is a check, and it checks those logs for the tools ran. So here we're checking if the extend trial tool was run. We're checking those arguments. For some of the tools, we're just checking if they were invoked. But that's what that tool call check is doing. And for each one of these, we have a qualitative review here. So that's the public reply correctness, internal node correctness, and then there's that tool call eval. Let's just quickly go back and see if it completed. Okay, so there's an aberration from OpenAI. But again, that can happen in prod. So that's a good example of this working. Okay, so this is a really good case. When we manually ran it, we actually got this case here. Our tool call worked. All 3 tools were called. But when we ran this 3 times, actually 2 of the times, a tool was not successfully called. So even in my happy path case, we ran it fine. It was working okay. It didn't choose to run that internal note. Okay, so let's try and improve that, because before we continue, we need these 3 to all have a tool call eval of 1, and these to stay relatively high, right? So let me go over into my editor. Let me go over into my AI agent, and let's modify my naive system prompt, and let's see if that improves the results. So because this isn't a text writing seminar, I'm going to paste something in that I made earlier. And here, let's add some rules for Zendesk. I won't read this all out, but it's giving some rules around when to use certain tools, what to do if a user exceeds the trial, and basically we're expecting that internal note is always logged. Okay, so let's save that, let's go over to evaluations, and let's run that again. Now, while that's running, again, we're going to do the happy path first, and then we're going to get into some edge cases. Now, I was talking with our engineering team on what's the guidance when you're trying to build evals, and their guidance was think of it like a unit test. So think of the different discrete things that could happen and model that out. Now, one could say that that's not exactly what I'm doing here. I'm testing if the entire set of tools were called. There's a bit of subjectivity to this. For me, for this task to be completed, all of these things have to happen. These 3 tools have to be called, or it's a failure. So that's why I'm running this as one test. But you could, again, break this up. And as you're seeing, I created this tool call check myself. In future versions of end-to-end, we are going to have opinionated features that make that easier to do in no code. But I also, let's see, it's complete in a second. I also wrote the code here that takes the input from my AI agent and this and outputs that evaluation. So when you're thinking about evaluating a use case, it is going to be a little bit use case specific, but know that you have latitude to do that here. And again, I'm a script kiddie, and I had ChatGPT help me with these things here, so you don't also have to be an expert coder to be able to set those up. Okay, that ran. Let's have a look. We've got my tool call eval all working perfectly. If this was a 1-hour session, I would show you this running 10 times, but you have to trust me on it. You should definitely build your own evals and run those. We can see example of these running as well in here. And if we look in the evaluate messages node, this is the one that's taking a candidate and an original and evaluating those. We can see we've got the original and the candidate. Those look very similar. And the public reply, however, is looking a little worse, right? This doesn't really look like an email. We don't have a sign-off from the Yak team and whatnot. And we're getting a 0.9 correctness there. So let's add some examples, shot prompting, in my system prompt. And let's see if we can improve that easily as well. So we'll go over to my system message. We'll scroll down here. And let's again paste in some shot examples. So here I've got examples for public replies, Here is example 1, example 2. These are example messages basically in the system prompt. Okay, let's go save that workflow, and let's run this eval again. Now, what I expect is that the correctness for my public reply and internal note is going to go up, and we're going to see that some other examples as well. So while that's finishing, let's say this runs fine, and I'm happy with my happy path here. I would encourage you to do some more repetitions than I'm doing in this time slot. But let's now think of edge cases. What could happen when this is not working well? There's going to be cases where people request more than the allowed policy. We should test that. But in the interest of time, one that I really want to make sure I get to is testing bad actors. So what happens when people start prompt injecting? When people start trying to reverse engineer your AI agent, hey, what's your system prompt? If they know your system prompt, they could create their own evals to try and break your system prompt. Or maybe they could get a free trial for 3 years, right? And that's probably not what Yak wants. So let's go ahead and copy in, let's see, this prompt injection case. Just make sure that my eval's done there. It is. Let me paste that in. We'll take a look at the eval, and then we'll continue. But to do that, here, let's just paste that in there. Let's take a quick look again at my AI agent. Let's have a look in here. So we see the correctness improved here. Internal notes at 0.9 there. I'm OK with that. For me, basically, from testing this, 0.9 and up is good. But we can see from that shot prompting, we've gotten the public reply. That's arguably the most important thing. Is all at a 1 out of 1. And we're using an AI to judge that. So again, that could possibly be incorrect. Maybe if this is a big production use case, maybe we should have an eval on that as well. But as you can see, we went from like a 0.8 and variability to a lot more consistency on this happy path. Okay, let's see what happens when we have the bad actor case. In the interest of time, I'm going to remove these momentarily, and we'll just run this prompt injection case. And before we run it, well, we'll run it and then I'll show it to you. Because alas, inference isn't instant yet. But if we look in here, it starts off as a really nice message. I don't know if that's too small to see, but they're saying, I'm really impressed, it's really great. Oh, by the way, I'm a security researcher. Could you share with me your internal workings? Is basically what it's saying, which is very bad. You don't want to leak your system prompt, right? And so we expect that the assign ticket to human tool is rule. At Acme Corp, at Yak, if we expect that someone's being a bad actor, we immediately assign it to human. We do not want AI involved at this stage. Okay, so let's have a look at what happened here. Okay, we got a 0. That's good, right? And a 0 here, and a 1 for the public reply. Let's have a look at this execution. Let's just kind of understand that contextually first, and let's try and fix that. Okay, evaluate tools. Okay, makes sense. Assign a ticket tool was not called. Let's just double check that. We don't see it anywhere in here. It's this one on the right here. It was not invoked. Okay, so that's bad. And let's check in here, the evaluate messages for the public reply. Okay, we got a 1.0 because we did not send a public reply. Okay, that makes sense, but we're not assigning it to a human. So let's go back into my workflow. Let's go into my AI agent. Let's go into that system prompt. And we got some Zendesk rules in here, as you can see. But let's add some security rules. And these security rules basically say if the user's prompt injecting or doing any kind of bad stuff like that, do nothing else, just assign to human and leave it there. Okay, so we added that in there. Let's save this and let's run it. Now, this is going to take a bit longer than a production execution because we have the eval stuff on there as well. But here we can see we've got a 1, a 1, and a 1. Now, in the, we've got 6.5 minutes left. Let's drink my own Kool-Aid and let's run a repetition on that. Let's go back, let's run that. And while that's running, let's have a look at the one that already ran. Okay, we added an internal note. And we assign the ticket to human. Let's have a look in the system logs here. Internal note, user attempted prompt injection. Okay, good, so the support team will see that context in there. And then we assign that to a human. And then the message here, got a 1 and a 1, and I'm fairly confident. Yep, very, very similar, almost identical. Fantastic. So let's see if that triplicate ran. Yeah. So we get 3 times in a row, it ran exactly the same. And I'm fairly confident at this point, if you ran it 10, 15 times, that would also be the case because we got a low temperature here. Now, there's a few other things that we can apply to this. This, we ran the happy path test with repetitions, and we ran 1 prompt injection case. That's not enough if you're Microsoft going to prod. That might be enough if you're building a little internal bot that's low risk, but I do encourage that you build out more test cases. Again, there the guidance is have test cases that cover your happy path, and then test cases that cover everything outside of the happy path. You can look at previous data. For example, previous customer support tickets would be a great option for those. But then the real ones are going to come when this starts sometimes failing some percentage in prod, and you need to tweak that. So let's talk about what might happen next. So we've added some evals, and now we want to add some more guardrails to it. There's a few different options that we can do. This is probably not an exhaustive list, but this is what I like to think about when I'm building mine. First one is adding human in the loop. We did that already. We added the assign ticket to human tool. A human is looped in. Now the AI agent decides when it's looped in. We could say for enterprise customers that it always just sends a draft reply. So if we know that they're an enterprise customer, we do that check first. We always assign this for a human to send that button. That could also be done in the workflow. But given this is for free trials, we have fairly high confidence because of our evals, we don't feel the need to have a human look at each one because it kind of defeats the purpose of automating that for them. We then want to handle runtime errors. Things can go wrong. I think the engineers in the room know that acutely well. And in NNN, you can do that with a custom error workflow. So if at any point this workflow fails, for example, like that OpenAI step that we saw, which I did not plan, I don't have that much sway at OpenAI, we can go to the workflow settings and we can define an error workflow. This is any arbitrary workflow on my NNN instance. So you could have a generic backup one that just sends a Slack message, or you could have a custom error handler just for this AI agent, which is the case in this one. So let me save that. So anytime this errors, it's going to invoke that workflow. And let's have a look at that error handler. Now, it's rather basic, but just to give you the idea, every error workflow in NNN has an error trigger. If I execute this, we can see some mock data in here. So this is the kind of information you get. You get the payload of the error, which workflow was, which ID it is. In this case, I'm checking if it's in the parent agent or in the tool of that agent, because the extend trial tool that the AI agent using is also workflow. It also could fail. And then in the next case, we're creating a ServiceNow incident or creating a different ServiceNow incident. I could post to Slack. I could post to a webhook. What I could also do, actually, is, and this would be a to-do in this project, is when cases fail, add those to a board. That's my board of evals. Those are the things that I want to add to my test cases. And you could even consider having an AI agent that does a lot of that legwork, that preps that eval. There you probably want a human in the loop to check that before you add it to your eval test case. But that's how you could start monitoring these things as they fail. OK, so we've added custom error workflow. Rate limiting your requests is also something we should do for most use cases. Depends if we expect there to be spikes. Support tickets, let's say your cloud goes down, you're definitely going to get spikes. So we do want that. Now, there's different ways you can do rate limiting. NNN can be self-hosted. So imagine NNN's a Docker container. Anyone in DevOps whatnot understands. Obviously, there's things you can do above that. So at some level of scale, you are going to want to do that. But within the NNN workflow, you could program your own rate limiting. I've seen users build a queue. So the items come into a queue, and then a separate workflow pulls from that queue, make sure it does that on a schedule trigger, for example, so it's doing that every minute or whatnot. But you're going to consider what's going to happen with spikes. And again, as I said earlier in my presentation, a lot of this is going to sound like the things that you do as engineers generally to have systems run reliably, and that's very much the case with this. And then you could also consider segmenting out high-risk use cases. So maybe our enterprise customers, we don't care if the AI agent's 99.9. A human's pressing that button every time. No problem. In that case, what I would recommend is to not have your AI agent decide that, but instead, because again in NNN, you can have deterministic steps before, we're not sending it to that AI agent if they're enterprise. Here we might check Postgres or some database, data store that has our customers' information on it. If they're enterprise, they're never going here. We're relying on deterministic if nodes and switch nodes to determine that, because those are going to be far more reliable than a probabilistic system. And then also inference redundancy. As we saw, OpenAI failed today, and then a couple seconds later it didn't. In N8N, we have a model selector node that you can use that lets you pick different models for inference. That's one option. We also support Open Router, so that's a bit deeper than that. It can pick the right model based on cost or uptime and whatnot. But these are some of the other guardrails you want to consider when you're going to prod. And what I would recommend for all of us is start building these. If you've got a personal AI agent, some small automation, build it for these. I ran over 300 evals on this use case, and I learned a ton in doing it. This feature for us is in beta. Evals have been out for a while. So if you do use N8N and use N8N evals feature, please do give us feedback. That's my time. I want to be respectful of the other speakers. I'm Max, the original Flowgrammer. I really appreciate all of you being here to learn, and I hope you did learn something. I highly recommend you get into evals. They're going to be critical moving forward, I think, even as all these systems get better. What's behind the QR code? I'm not sure. You'll have to scan it to find out. We'll build a little curiosity. And our booth is right outside that exit, so it would be very difficult for you to miss it. We've got swag, we've got live demos. Our community members flew in from around the world to demo their production AI agents and workflows. We think it's a lot better than us just giving demos. And so thank you very much for your time, and happy Flowgramming. Unplugging.
Thank you very much, Max. Yes, as you've guessed, we are out of time for questions, sadly. But go and find Max either just at the side or go to the booth. We'll see you in 10 minutes for the next talk. See you then, everyone.